Hey there, in this video we're going to talk about random numbers and creating random values for our Python programs. Now, number one, most important thing we have to discuss first is, are the values truly random? And the answer is no. A computer is not going to generate truly random values for you. It's going to generate values following some kind of algorithm that makes values that dance around a lot, that look random to a person who in general is really bad at detecting random as it happens, but are not actually in the purest sense random. It is possible to build hardware that creates random values by observing something in the environment, but that is not what your computer uses. It uses some kind of algorithm. Let me show you one of these popular algorithms. I don't think this is the one Python uses, but I know it's been used in C, historically at least. We need to make some kind of starting value. That's called the seed for our random number generator. And once we've set that value, it is entirely deterministic what values are going to follow. So we're going to create new values for x based on old values by evaluating 7 to the 5th power multiplied by x, and we're going to modulo 2 to the 31 minus 1. And I think we already have the order of operations right, but let's just drop in some extra parentheses just to be sure. Let's start printing x. I'm going to do Control Enter here just to stay at the same cell. So hitting Control Enter over and over again, I get numbers that seem to dance around. They're all really big. Typically, when we generate a random number with a computer, we generate it in the range 0 to 1, and then we can rescale it if we want it larger. So to put us in that range, we just have to divide by 2 to the 31 to do it. Oh, that's supposed to be, I had a multiplication. I wanted exponentiation there. That's better. So now I can generate values in the range 0 to 1, and they seem like they're dancing around randomly, even though it's just following some kind of deterministic algorithm. So these kinds of random numbers are called pseudo-random numbers. They look random, but they aren't. There's actually some underlying patterns that can be very bad if you're doing something like, say, I don't know, running a slot machine, because then somebody who knows the pattern can watch the slot machine for a long enough time and then predict when the next jackpot is going to be and make sure they're sitting there. For our purposes, though, the algorithms built into Python will be good enough. We'll be fine. So to get access to the random numbers, we can import the random module and call random.random to get Python's version of values in the range 0 to 1. We keep calling this, we'll get values that seem to jump around, following some kind of algorithm, but appearing random. One advantage Python's going to have over the version we coded is if we start at 1, we always follow the exact same sequence. Python automatically seeds its random number generator, I think, by looking at the current time. So unless you start code at the exact same millisecond or nanosecond or whatever it's looking at as somebody else, you will get a different sequence. It'll still be some kind of algorithm generating the sequence, but at least it won't follow the exact same order. There's more stuff in the random module than just random. So we can check it out by hitting tab here, give it a moment to pop up. We can see, all right, there's a bunch of good stuff in here. I'm going to show you some of the most useful functions. Let's look at random integer. This would be good for simulating, say, a dice roll where you have discrete steps like 1, 2, 3. Our arguments that go in here are going to be this range A through B, including both endpoints. So if I wanted to make a 6-sided dice, I'd go 1 to 6, and then if I start rolling that, I definitely got 1. Let's see if I can get a 6. Boy, am I unlucky. Oh, there was a 6. Okay, so sure enough, it includes both endpoints. Close cousin of this is rand range. Let's just make a new cell here. Random range is start, stop, step, and it doesn't include the endpoint. So if I go here 1 to 6, then default to a step size of 1, and start running this and roll this dice, I'm never going to get the 6. So kind of a subtlety here between these two. I do have the option to set my step size, so let's say I only want odd values. I'll get 1, 3, 5 as the only possibilities. If you want to draw a random number from the normal distribution, also called a Gaussian, that's going to be random.gauss. The arguments in here are going to be mu is the average and sigma is the standard deviation. So for, let's say, a mean of 4 and a standard deviation of 2, if we start generating values, we're going to see our values are going to be generally around 4, but they can differ by up to 2 or a few factors of 2. But it's unlikely that I'm going to generate a value like 1,000, because that is many standard deviations away from 4. Other things we might want to do with the random module is to shuffle a list. So let's say I've got some kind of list, like let's do Jenny's phone number, 675-309. And I want to scramble it. I can use random.shuffle, give it the list, run that. Oh, I spelled shuffle wrong. Silent W. Okay, now you notice I didn't say L equals, I just shuffled the list. I've changed the list itself, so now it's the phone numbers in a random order. So be careful of this one, it's kind of like sort, it changes the list in place. We can pick a random thing from a list using choice. Random.choice, choosing from L, this is the scrambled version of L, but it doesn't really matter. It will randomly pick one thing out of that list. So it picked 5 for us, but as we call it, it picks different things from the list. Okay, and then the last thing to look at here is setting the random number seed. So I mentioned before how Python, when you call random, actually any of these, starts your random number generator by looking at the current time, so that it'll be unique each time you run it. Your sequence of random numbers will be different every time you run it. Like if you've been running your code as following along with the video, you will have gotten different numbers than I've gotten, or they'll be in different orders than the numbers you're seeing. But we can force the orders to be a certain way by setting the seed. And the reason you would do this is for reproducibility in your code. So you're running some kind of program, and let's say it crashes or it does something unexpected. Then what you can do is set the seed so that you know exactly what sequence of random numbers you'll get, or maybe you don't know, but your computer will always generate the same sequence of random numbers, and so you'd always get the same results. If you're into video games, you may hear about people talking about seeds in video games. That's for setting the random number generator for the video game so that the same sequence of things will always happen. At least if you did everything exactly the same as someone else, you'd see the exact same sequence. So let's seed our random number generator with, let's go with Jenny's phone number, 8675309. It's like the only long number I know. And let's make a sequence. So we'll do for I in range 5, print some random numbers. Can't spell. All right, so we're going to print random.random. And we got 5 random numbers. Not just any 5 random numbers. If you've run this at home, you should get the exact same 5 random numbers. In principle, this could change between different versions of Python. In practice, I don't think they've really messed with the random number generator in quite a few years. So if I run that and then I run it again, then I run it again, run it again, run it again, it's the same every time. If I take away this statement of set the seed and I run it, then I get a changing list of random numbers because it'll seed in the background by looking at the current time. Okay, so in this video, we've talked about how to use some of the functions out of the random module that let us generate random numbers that we can then use in our code.